Section 10.4 is about area and circumference. So when they're talking about area, they're talking about the inside of these two-dimensional shapes. In the last video, we talked about perimeter, which was the outside, but now we're switching gears to area, which is the inside of these shapes. A great real-life example of that would be if we were going to carpet flooring, so we're filling up the inside of flooring. The units here are going to change. So most of the time in real life, and always in this course, when they ask you for area, your units are going to be squared, raised to the second power. So for example, if the original problem mentions feet, the area will be feet squared. If the original problem mentions meters, the area will be meters squared, and so on and so forth. Why is it always going to be squared for area in this course? Is because you're going to be plugging into a formula where you're multiplying that unit times itself. You'll be doing like feet times feet for feet squared, or yards times yards for yards squared. Circumference is a little different. So circumference is actually the perimeter, or the outside, of a circle shape. And because it's perimeter, the units will stay the same, just like they did in the last video. So when we get to circumference, it's like you're going to build a fence around your circle, so the units will stay the same. Because it involves a circle, you are going to need a formula. I know in the last video, when we did perimeter, we did not need a formula, but when we're dealing with a circle shape, you are going to need a formula because it's going to always involve the number pi. With area, you're going to always need a formula, no matter if it's a circle or not a circle shape. So it's really important that you can identify the shape they throw at you first, so you know which formula to implement for area. So area, you're always using a formula. So just going through some of these slides that we talk about the formulas here we'll use. They have A for area. So if they give you a rectangle shape, the formula for area of a rectangle is length times width. So just simply multiply the length times the width. For a square, you're going to take any side and square it, or since a square is a type of rectangle, you could also use the rectangle formula and do length times width. So many choices to get the right answer. For a parallelogram, you're going to take the base B times the height H. And if you look closely, the height is not a side on the parallelogram. The height is going to be located beside a dotted vertical line inside the parallelogram. So you're doing, again, the base, which is the bottom, times the height, which will be beside that dotted vertical line of a parallelogram that looks like this. The only time the height will be an actual side is if your parallelogram is a rectangle or a square. Then the height would be the same as the width. And then on the bottom of this slide here, they talk about the area of a triangle. Since a triangle is 1/2 of any parallelogram, you're going to do 1/2 times base times height. So 1/2 times the bottom, B, times the height, H. And finally, the area of a trapezoid. Remember, trapezoid's kind of a weird shape. Whenever you have just one pair of parallel sides, that's it to be a trapezoid, and also a quadrilateral, so four-sided shape. But that's it for criteria for this weird looking trapezoid. The formula is a little bit messy looking as well, but to find the area of a trapezoid, you're going to take 1/2 times the height, and if you want, you could put more parentheses around the height in the middle there, just to kind of emphasize that you are multiplying. So 1/2 times the height h, which is not even a side on the trapezoid, times a plus b. And a and b are the parallel sides. So a and b represent the parallel sides. Please notice that you do not use the slanted sides at all when you're finding area anyway. So not at all did I use this slanted side or this slanted side in my calculation of area of a trapezoid. So I want to go ahead and draw like a little divider because example 1 has nothing to do with a trapezoid. So example 1 is actually going to deal with a rectangle shape. It's a little bit trickier because they changed the units on us. So this is going to be a 3-step question. So looking at example 1, it says, what will it cost to carpet a rectangular floor measuring 18 feet by 21 feet if the carpet costs $16 per square yard? So they're mentioning carpet. So that tells me that at some point we're going to have to figure out the area of this shape. Now, I'm going to do this a little bit differently than in the last video when we changed units. So even though this is a 3-step question again, I want to convert units first. Because notice the original dimensions of the floor were given to us in feet, but then the price quote, they changed it to square yards or yards squared. So step 1, convert the units right away when it's an area question. So remember, when you're going from feet to yards, that is when you're going to divide by 3 because there are 3 feet in 1 yard. So let's go ahead and draw our shape. It is a rectangle shape. And they said that it's measuring 18 feet. So 18 divided by 3 means that 18 feet is the same as 6 yards. So one side of the rectangle is 6 yards. The other side was 21 feet. So again, we just simply divide by 3 to convert that to yards. And we see 21 divided by 3 is obviously 7. So 21 feet is the same as 7 yards. So in yards, 18 feet by 21 feet is the same as 6 yards by 7 yards. So just simply divide the feet by 3 to convert to yards. So now, step 2, once you've converted first, now let's find the area. We said the word carpet means they want the area. Area, we need a formula. So look at what shape you're given. You're given a rectangle shape. What's the formula for area of a rectangle? We said on the last slide, it's length times width. So to find the area, just simply multiply your 2 sides together. So our length was 7 yards times our width was 6 yards. So I do 7 times the 6. So this was our length and this was our W. So I do 7 times 6 and it's 42. Now remember, the units change as soon as you use the area formula. It's no longer yards, it's now yards squared. So I have a little exponent of 2 above the word yards. Why? Because when I plugged into the formula, I actually did 7 yards times 6 yards. So I did yards times yards is why it's yards squared. Just like in algebra, when you did x times x, you got x squared. So when I do yards times yards, I get yards squared. So I need 42 square yards, or yards squared, you can say it either way, to carpet this floor. So now I'm ready for the last step. Step 3, it wants the cost. It says it costs $16 for every square yard. So I just multiply. So it's $16 times, I'll use parentheses for times. We just said in step 2 there are 42 square yards to carpet. So if I do 16 times 42, I get a final answer of 672. So 672, final answer for example 1. So now we have a bunch of just simply find the area, what are the unit type questions. So looking at these quicker questions, example 2, find the area of each figure, write the correct units. Now remember, area is a little harder than perimeter because we do need to implement a formula to find area. We also need to square the units. So looking at A, we said it's a 2-step process. So step 1, as I look at A, it is a rectangle shape. Opposite sides look like they're equal, and we have all 90-degree angles is how I know it's a rectangle shape. Once you've identified the shape, step 2, look up the formula to implement. I do have formula sheets uploaded in our Canvas course. If you take a look at the buttons on our class homepage, you can find those formula sheets. But the area of a rectangle is length times width, so I simply multiply these two numbers together. So the area is, the length was 6 meters, m for meters, times the width was 3 meters. So I do 6 times 3 for 18. Be so careful with the units, please. It's meters squared. So in this course, when it asks you for area, look at the units in the original picture and always square them. So 18 meters squared is the final answer for part A. Now let's look at part B. So same directions, it wants the area. As I look at this shape, I notice that the opposite sides are equal. And also the opposite sides are parallel. If I extended them out, they would never ever intersect. So this must be a parallelogram. Whereas if all the sides were equal, but it does not have right angles, it would have been a rhombus or a diamond shape instead. But here, step 1, this looks like a parallelogram since those opposite sides are parallel and equal. So now step 2, if you look up the formula for area of a parallelogram, it's base times height. So they gave us extra information we're not going to use in step 2, so be very careful here. So base is the bottom, which is 50 centimeters, times the height is the number beside the dotted vertical line. That's not a side, in this case, of the parallelogram. The height is 42. So I do not need the 44 at all in the area formula. So it's just 50, the bottom, times the height, 42. And when you do 50 times 42, you get 2,100. The units of the original picture were centimeters, but you should automatically square your units whenever it asks for area. So 2,100 centimeters squared, or square centimeters, you could say it either way, is the final answer for part B. Looking at example 3, yet again the directions are find the area of each figure and write the correct units. As I look at A, this is clearly a triangle shape. So we still identify the shape first, and then we look up the formula for it. The formula for area of a triangle is 1/2 times base times height. So the base So it's 1/2 times the bottom base is 14 times the height besides the dotted line is 8. And when you type this in your calculator, it's up to you if you want to type in 1 divided by 2 for 1/2, because remember, fraction bar just means division, so you can just hit the normal division button if you want, or you can write it as 0.5. The decimal equivalent, that works too. So when you do 1/2 times 14 times 8, you should be getting 56. The original picture was the inches, so you're going to do inches squared for the units. So 56 inches squared is the answer to the triangle's area of part A. Part B, be so careful with. So when you look at the shape, none of the sides are equal. It's a pretty ugly shape. The only two things I'm noticing is that it has 4 sides, because I don't count the height as a side. So it does have 4 sides, and it has exactly one pair of parallel sides. The 26-meter side and the 37-meter side are parallel. If I were to extend those sides out, they would never ever intersect. So a quadrilateral shape with exactly one pair of parallel sides is a trapezoid. It looks nothing like the trapezoid example that we've seen on a previous slide, but it is a trapezoid because it does match the definition in the last section's video that you watched. And the area for a trapezoid we mentioned on a previous slide in this video is 1/2 times the height h times A plus B, where A and B represent the parallel sides. So the area is 1/2 times the height is 18. The parallel sides you can put in any order, so I'm just going to say that A is the bottom was 37 plus the other parallel side is 26. If you are doing this with a lesser version calculator, you would do inside the parentheses first. I have a graphing calculator, so I'm just going to throw this mess just like that right in the graphing calculator. So to type it in, we said you can either type in 1/2 or 0.5. I'm just going to write 1/2. So that's 1 divided by 2. And you can use either the times button, or you can even use these parentheses right here above the 8 and the 9 buttons for times. I'm going to use the parentheses because I really want it to look very similar to what I have written on my paper. So 1/2 times, we said the height was 18. Close those parentheses. More parentheses. A plus B, the addition of the parallel sides, which was 37 plus 26. 37 plus 26, close those parentheses, enter for equals, and you should get 567 as the final answer. So jotting that down, the area is 567. The units of the original picture were m for meters, but we should square them whenever we're talking area in this course. So 567 meters squared is the final answer for the trapezoid in part B. The last few questions are going to ask us to find the circumference and area of circles. Before we can do that, we need to make sure we are familiar with some of the vocabulary for circles. So we do have the center of a circle, which is right smack in the middle. And then sometimes they'll give you the radius, but other times they'll give you the diameter. So the radius of a circle is any straight line segment that goes from the center to an actual point on the circle itself, and they'll use R for radius. So any straight line segment that goes from the center, pretend I can draw straight, to the circle itself is the radius. The diameter is a little bit more. So the diameter, which of course they'll use D, little d for diameter, still touches the center of the circle, but it goes from one side of the circle through the center to the opposite side of the circle. So the relationship between diameter and radius is, if they give you the diameter and you want the radius, you cut the diameter in half. In other words, you divide by 2. So for example, I'll write a little example up here. Let's say, for example, they tell you that the diameter is, I'll just make up a number, 8 meters. The radius, R, you just take the diameter, 8, and you divide by 2. That's it. So if the diameter is 8, the radius would be 4 meters. Or let's say the diameter was 20 inches. And you want the radius R. Again, when you have the diameter, to get the radius, you just simply divide by 2. I use fraction bar for division here. So 20 divided by 2 is obviously 10. So if your diameter was 20 inches, the radius is 10 inches. So you divide by 2 to cut it in half. Because you can see on the picture of the circle on the right, each radius is 1/2 the diameter. The formulas are on the bottom 2 yellow boxes here. So if you want circumference, which is the perimeter, the outside of a circle, you're going to take the number pi times the diameter, or you could also do 2 times pi times the radius. Either formula, it's your choice, will give you the circumference C. The area, the inside of a circle, is pi times the radius squared. Notice that only radius is squared, raised to the second power. The number pi is not squared here. Looking at example 4, it says find the circumference and the area of the circle. Express each answer in terms of pi and then round to the nearest tenth. So what's kind of a pain in the My Math Lab is they want 4 total answers because they want their circumference written in 2 different ways, and they want the area also written in 2 different ways. So we're going to have 4 total answers by the end of this question. So keeping that in mind, before we begin, we're going to look at the picture and we ask ourselves, whenever a circle is involved, did they give us the diameter or did they give us the radius? So as I look at this picture, I see that the 12 yards is referring to the line segment that goes from one end of the circle through the center to the other side of the circle. So that means that this 12 yards is the diameter. So they gave us diameter is 12 yards. If they just gave us from the center to the circle itself, that would have been radius instead. But here it goes all the way across that line segment, so that's the diameter. So let's start with circumference. So the circumference, C, remember, if you look at the previous slide, you have 2 choices to get the circumference. Because we know the diameter, it's slightly quicker to use the pi times diameter formula. So I'm going to do pi times diameter, which we just said is 12. And now let's go ahead and format this answer like the My Math Lab wants it. So you would type in the whole number first, so bring the 12 to the front. Then you would type in the number pi using the answer template that'll appear below the answer box. The units for circumference are the same as perimeter, so the units stay the same. as the original picture for circumference anyway. The original picture was in yards. So 12 pi yards is the first answer that goes in the first answer box. So when they say in terms of pi, they want the answer in terms of pi, this is what they mean, meaning leave pi alone. Pi is going to be part of the final answer. So in terms of pi means you will literally use the pi button from the answer template to put the number pi in as the final answer. By the way, pi looks like this. It is an irrational number, meaning it's a decimal that never ends, nor does it repeat the same pattern. It's approximately 3.14159, approximately, but it does go on forever. But 12 pi yards is the first answer they're looking for. Now, they still want circumference to go into the second answer box, but they want it rounded to the nearest tenth. So when they want the rounded answer, it means you're going to use the pi button on your calculator and round accordingly. So let's go ahead and type in 12 times pi into our calculator and round to the nearest tenth. Typing in 12 times pi, I would put the 12 in first. Now pi is above the exponent button, the up arrow. So you're going to have to hit two buttons to get pi in there. You're going to hit second. An arrow will appear inside the cursor, and then up arrow. I do not have to hit times. I can just mush the 12 and the pi together, and the calculator, the graphing calculator anyway, knows that means times. So I have 12 pi. I hit enter on the main screen. You're going to get a weird decimal. It wants us to round to the nearest tenth. That's one digit out. Remember, when you're rounding, you only care about the digit after where you want to round to. So the digit after is a 9. If it's 5 or greater, you're going to round up. If it's less than 5, you'll leave it alone, meaning round down. So because it's a 9, I get to round the 6 up to a 7. So that's about 37.7 as the final answer. But again, to get pi into the graphing calculator, you hit second, followed by the up arrow, the caret. And you'll know if you've done it correctly because it'll come onto the main screen. If you use 3.14, you will not get the right answer because you'll have too much round off error. You do need to use the pi button in the calculator to avoid as much round off error as possible. So we did get approximately, I did put the approximately wave there, 37.7. And the units still stay the same because it's circumference, so I'm going to leave it as yards for now. So when it says rounded, it means use the pi button on the calculator. So we have the two ways of formatting the answer for circumference. So 2 answers down, 2 to go. So now we're ready for area. If you look up the formula for area of a circle, it's pi times the radius squared. There's a problem here. We don't have the radius. They gave us diameter. So we need to quickly figure out the radius. So if the diameter is 12, remember, you take the diameter and you just simply divide by 2 to get the radius. So if the diameter was 12 yards, the radius must be 6 yards. Be careful because they're going to try that little trick on you throughout the homework. So you got to be really careful if they gave you diameter or radius because they only want radius in the area formula. So let's plug in the radius 6 into the formula. So that's pi times 6 squared. Let's clean up our answer a little bit, bring down the number pi. I'm only going to do 6 squared first. So do the whole number squared, radius squared. So 6 squared meaning 6 times 6 is 36. Notice that even though I did 6 squared, I left the 36 in parentheses because I want to emphasize we are multiplying that 36 by pi. Now let's reformat it like the homework wants it. So you would type in the 36, the whole number first, then you would type in pi. The units for area are always squared. So the original picture was in yards, but I will automatically square those yards because now we're talking area, the inside of the circle shape. So in terms of pi, I'm going to have 36 pi yards squared as my first area answer. This would go in the third answer box of this really long question. And now it wants it rounded to the nearest tenth. So you're going to type in 36 pi into your calculator. When you type in the 36 times pi and you hit enter, you should be getting about 113.1 roughly when you round to the tenths spot, and the units are still yards squared. So you'll notice I've circled or boxed 4 total answers. You would type in all 4 and you would select the correct units even from a drop-down answer box in the homework. So beware of any circle shapes in the homework. They do want the answer both in terms of pi and rounded.